I'm Carlos. I'm Daniel. Same last name, Marquez. These are our brainstorming sketches, basically. Those first two were Daniel's, and he went with like a more high cost but like real good approach to it. Like most of his bridges were like around 800,000, 700,000, or like 900,000. I went more with like really cheap and simple, like that bottom truss, and we sort of mixed our final design with that. This is a design matrix, basically a cheap bridge, art bridge, and art cheap are our names. We didn't really go for names. Daniel's bridges were art bridge and bridge, which were very like high cost and were like not really how do you say manageable to make. Then my bridges were cheap but were really ugly, like were not very good aesthetically, so we went with the art cheap in the end, which was a mixture of our bridge and my bridge and his bridge, which worked out okay.
So our problem was to build a sustainable or successful bridge so that we can have a truck drive across, and we have to make it 32.5 meters from the riverbank, maximum of 50 and 50 joints and 120 members, and carbon steel, high strength, low alloy steel, or quenched tempered. Solid bar or hollow tube. And for research, basically we just chose what the cheapest was, the cheapest materials, and we used a pier so that it can actually help us kind of
sustain it and make the bridge cheaper.
Yeah.
Because the pier you use less resources, like in general. So. Oh, and then we kept that at 0 meters because that was the cheapest possible way to do it. Because it's a small bridge, you don't have to use as many members on it, and the concrete was revenue because we didn't need another one. Well, the thicker the bar, the more expensive it is, but the stronger it is, which we try to incorporate by making some bars smaller, some bars bigger, and we also kept some parts of it smaller as well. And then the diagonals help the bridge stay like better in tension and compression. Yeah, just some. These are our questions, right?
So direction matters. Like if you want your bridge to be better in compression or in tension, both compression and tension can work together to build a successful bridge, because the load can affect both. Consensus means a general agreement. You usually want consensus because you don't want to stay on a topic for too long. And the properties and materials affect the solution because, of course, they make it stronger or cost more or cost less, stuff like that.
As you can see here, most of our members were a mixture of hollow tube, solid tube. They're all different lengths and sizes, so we try to make it as cost effective as possible. And yeah, our final design, our materials were carbon steel, solid tube / hollow tube to make it cheaper. Our compression force was 0.07, which is 7% of compression was on it, and it could take 100 more of that. And then 3% for the tension force. And our cost was $295,000, and we used 29 members. Oh, and the reason why the top part, there's the top part right there was to add a better look to it, because we didn't really need that, to be honest. It's on there for no reason, but we just wanted to make it look cool.
Thanks.
There's our bridge in action. It doesn't really move too much, except right here. Alright.
Give him a hand.